For the last 2 years, software development relied on copilots, tools providing autocomplete suggestions for single lines. Now, that architecture is branching out. We have crossed into the era of autonomous agents capable of independent, long-horizon task execution. At Walmart, the transition is already quantified. By deploying specialized domain agents across their infrastructure, roughly 40% of the company's new enterprise code is now generated or supported by AI. Across the broader industry, the adoption baseline is virtually total. 85% of professional developers now rely on AI tools in their regular workflows. But this scale has introduced a severe contradiction. This split-screen chart highlights the problem. While major trials show AI driving a 55% increase in task completion speed, developer trust has plummeted. Only 29% of developers actually trust the accuracy of the output they are generating. We are experiencing the maintenance paradox. Solving the syntax bottleneck has not eliminated work. It has triggered a severe logic and security crisis in production environments. To understand why this paradox exists, we have to look at how these systems operate. Standard large language models are highly constrained. Ask them to complete a multi-step engineering task, and they reliably lose context or derail after 4 or 5 sequential steps. Agentic architecture solves this by managing computational state. Instead of treating every prompt as a fresh instance, the agent maintains a continuous memory across thousands of iterative steps, tracking test failures and adjusting its approach. This schematic illustrates the agentic workspace, an LLM core connected to a Linux shell, code editor, and web browser. The AI writes and tests code autonomously. On the SWE bench evaluation, this pushed success from GPT-4's 2% to over 13%. This architecture shifts the AI from a tool that predicts the next line of code into a worker that plans, executes, and revises multi-file systems. The most rigorous test of an autonomous agent is brownfield modernization, the tedious, high-risk process of refactoring legacy code. Nubank recently deployed agents to tackle exactly this. The scale of the Nubank migration was massive, an 8-year-old monolith repository containing over 6 million lines of code, requiring the extraction of 100,000 data classes into modular subcomponents. As we see in this diagram, automating the extraction process yielded intense efficiency gains. By fine-tuning a fleet of Devins on manual migration examples, the engineering team achieved an 8 to 12 times increase in efficiency and a 20-fold cost savings over a human team. The quantitative proof of these gains at scale comes from a randomized controlled trial conducted by GitHub and Accenture. Testing thousands of developers in real-world settings, the trial recorded a 55% increase in task completion speed, accompanied by an 84% increase in successful builds. The most striking metric was the compression of review cycles. Pull request turnaround times dropped from 9.6 days to 2.4 days. The data confirms that AI completely dominates well-defined repetitive tasks. The industry has effectively commoditized the first 10% of the build, the boilerplate generation and the test scaffolding. However, high volume does not equal high efficacy. A separate randomized controlled trial conducted by Metra tested highly experienced developers and found the exact opposite of the Accenture results. When senior developers were asked to work on familiar code bases using AI assistance, they actually measured 19% slower than when coding manually. The slowdown is driven entirely by cognitive overhead. The time saved generating syntax is immediately consumed by the burden of prompting the agent, context switching, and forensically reviewing the output. This visualization shows the primary risk: specification collapse. The agent generates code that perfectly passes a syntax linter and looks clean in a pull request, but fails the architectural data flow because the underlying logic is wrong. Analysis from CodeRabbit quantifies this exact failure mode. AI-generated code contains 1.7 times more logic issues than human-written code. These logic bugs are insidious because they bypass standard automated testing. They compile flawlessly, but perform the wrong action when deployed to a live production environment. The direct consequence of specification collapse is a massive tax on senior talent. According to Google Dora, companies with 90. This table from Veracode reveals the exposure. Compared to human-written code, AI output contains 2.74 times more vulnerabilities overall. nearly double the insecure object references, and 2.74 times more cross-site scripting errors. Crucially, this is not a problem that scales away with compute. Newer, larger models do not produce more secure code. Security pass rates have flatlined between 45% and 55%, regardless of model generation. This has generated a shadow AI crisis. Currently, 80% of Fortune 500 companies are deploying these tools across their infrastructure without a formal governance strategy. Traditional identity and access management fails entirely here. Legacy systems were built for humans, not for dynamic, ephemeral AI agents that spin up, execute a task, and terminate in minutes. Because they lack strict identity boundaries, these agents inherit broad, standing permissions across networks. This creates massive credential sprawl, leaving permanent security exposures long after the agent has shut down. In response, the industry is racing to implement AI bills of materials and model context protocols, systems designed to create an immutable audit trail for machine logic. Until those protocols mature, deploying autonomous agents without cryptographic identity verification means enterprises are scaling their security vulnerabilities at machine speed. The maintenance paradox is permanently restructuring the labor model. The traditional tiered engineering pyramid is dissolving into the AI pod. Under this model, a single senior engineer acts as a pod lead, orchestrating an entire swarm of agents and replacing human teams that previously numbered 30 or 40 developers. Goldman Sachs has already embraced this hybrid workforce model, intending for AI agents to absorb 20 to 40% of the firm's total engineering workload. The immediate economic consequence is the complete commoditization of the bottom layer of software engineering tasks. The labor market reflects this shift. Companies adopting generative AI are currently cutting junior developer hiring by 9 to 10%, while senior headcount remains flat. This creates a severe existential risk for the industry, the destruction of the traditional apprenticeship pipeline. We are removing the bottom rung of the ladder. Engineering requires muscle memory, the deep structural intuition built by manually solving basic problems. If junior developers never write the boilerplate, they will lack the architectural intuition required to supervise agents when those agents inevitably fail. The software industry is bifurcating. On one side, legacy systems of record. On the other, highly capital-efficient AI-native systems of orchestration built from the ground up to support autonomous workers. Industry leaders project that 90% of all code will soon be automated. Developers are moving toward vibe coding, leaving line-level editing behind entirely to focus on high-level behavior and interface rules. In the agentic era, software engineers are no longer typists. The institutions that win the future will not be the ones with the fastest coding agents, but the ones with the most rigorous architectural, security, and ethical oversight.